Alright, so the first part was without relays. The second part's going to be using these two contactors that I have here. I'm going to introduce the second fuse block down here. You can see it's on another plate. I've got a low voltage terminal block, my two contactors, my fuse block, and L1, L2, L3 lugs, possibly not in that order. I've got L3, L2, and L1. I've got them all color coded just to try to help out the understanding as much as possible. We're not going to use this fuse plate or the fuse block, excuse me, or these lugs on the top side for this heat strip. We're just going to come from this bottom plate up. I'm going to go ahead and just bring L3 down, tie it to the lugs, come off pigtail into the fuse block. I'm going to come over and take L2 to the lugs, come off pigtail over to the fuse block, and then we're going to take L1 over to the lugs, come off pigtail over to the fuse block, and that's pretty much all that's going to look like. Now, just going over the top side here, all these ovals are limit switches. I'm just going to put LS on all of them. And when I did part one, I didn't wire up these two middle limit switches. I'm reserving that for my contactors, one for each contactor, so I can run low voltage through it and knock it off. If I were to do that, pretty much how that would look would be very simple. Let me go ahead and start with common. Common's going to come over and land on both sides of my contactor. If you look at the contactor, I'm not running it to the load side or the line side. I'm actually wiring it up to the coil side. You can't see in my image because it's only showing these bottom terminals that are for the high voltage, right? But if you were to look at my contactor that I'm holding in my hand, you'll see that I have the coil there, and that's what I'm running my commons to. I'm going to go ahead and knock out the low voltage side, and then I can erase that and we can focus on the high voltage. So commons coming in parallel, and then our W2 is going to come up, and we're just going to run it up to one side of the limit switch, providing the limit switch is closed. It'll come over to the contactor. Okay, we'll come over to the other side of the other limit switch, come out of it. As long as that limit switch is closed, it'll provide 24 volts to the other contactor. And that's pretty much it. We talked about blower safeties. The blowers need to run with these limit switches. Nice thing about these limit switches here, by having high voltage and low voltage separate, so I have safety on both ends, one on my low voltage side, one on my high voltage side. One of the benefits there is with this contactor, I'm about to take 3 heat strips. I have 6 heat strips up here. I have 1, 2, 3, 4, 5, 6. 6 sets of heat strips, right? And with that, I can knock off any one of these sets with opening one limit switch, right? If I were to knock off one of these limit switches here that are on the low voltage side, it's going to knock off 3 heat strips. So if I'm not getting enough, air across these strips, and I open on temperature rise, it's just too warm in the plenums, if there's a problem. It could be anything. I can have a damper not open up. If I have a duct passing through a firewall, you may have the belt even slip off over that too. The fire damper closes, or there's a defect or whatever. That's going to cause these limit switches to open. Belt slipped off, motor not running, not getting a G call, whatever the case may be. Anything that creates an airflow problem. These limit switches are there to open on temperature rise, so we don't have a safety issue. So by having limit switches on the low voltage side, one going to each contactor, then I'm enabling 50% shutdown on these strips while I'm still reserving the other 50% if there's a fault on the limit switch not closing again. Because remember, its job is to open up if there's a problem. Sometimes they don't close when they're supposed to. And that would be better than running everything through one limit switch, where I have less ability to come back on if there's a problem with the limit switch. All right, so I'm going to go ahead and erase the low voltage so there's no confusion as we put more lines on the board. It's just going to get confusing as we start drawing all over it. All right, and we won't even write limit switches back on here. We know what that is now. Okay, real simply, I'm going to say that L1 comes on one fuse, goes to one contactor. L1 comes through one fuse and goes to the other contactor. L2 goes through one fuse, okay, goes to one contactor. L2 goes through one fuse, goes to the other contactor. You see, everything's just a 50-50. L3 comes one fuse, goes to one contactor. L3 comes up one fuse and goes to the other contactor. I'm just going to put the colors up here just to keep things a little bit easier for us. Let's say that's red, middle's red, and we have black for L1, black for L1. All right, and so now all we're going to do is we're going to split our heat strips. Remember, there's 6 of them up here. We're going to split them 50-50. All right, so we're going to say, all right, we're on black, so we're going to use black. We're going to come up and we're going to come over and we're going to come into the limit switch, out of the limit switch, into the heat strip. Okay, there's one. We're going to come out of this side. Like we said in part 1 video, this limit switch, if it's open, is going to affect here and it's going to affect here, right? So it's going to affect this strip and now this strip. Okay. All right, so we have one strip done. All of our L1 is complete. We're going to go ahead and go to L2. We're going to tie into the limit switch, come out of the limit switch, tie in here, and then I'm going to come over and just use this top section. Okay, so as long as this limit switch is closed, I have power here and I now have power on this top section. And then that is one section, 2 sections. We only have one more to do. We've got 2 red, we have 2 black, now we got to knock out our blue. So our blue, pretty simple. I'm going to come up, I'm going to take the long way, I'm going to come into my limit switch, I'm going to come out of my limit switch over to one side of my heat strip, and providing that limit switch is closed, I can now come over to my other side of my heat strip for L1, and now I have completed 50%. And what's left over? We have this section, and this section. So I'm going to go ahead and we're going to go ahead and name this. I'm going to use green since I think it'll show up really good. We're going to say this is 1, this is 2, and this is 3. All right, so there's our 3 sections. So, and I'm only coming off of one contactor. So if I lose a fuse on L3, L2, or L1, you know, I'm going to lose the ability for 2 heat strips to work. So if I lost, let's just say this very first fuse on the left-hand side, which is on L3, all right, well, that's going to affect heat strip 1, and that's going to affect heat strip 3. However, heat strip 2 will still work, okay? If I went off the beginning of part 2 video and I lost a limit switch on the low voltage side and the whole contactor doesn't pull in, or if my contactor just failed, then I have 3 heat strips, 1, 2, and 3 that are out. This is really nice to be able to separate it so I'm not just knocking the entire 100% out of order. We're going to go ahead and wire up the other 3 heat strips using the other contactor. Okay, so we're going to come up and we're going to go to the limit switch, add a limit switch over to the heat strip. Okay, we're going to come out of the heat strip over to the second heat strip on that contactor. Okay, so as long as the fuse is good to go, I have power. As long as up here, as long as the limit switch is closed, I have power here, and then I have power here, and as long as that limit switch is closed, I have power up here. All right, we're going to come over to L3, and we're going to come into the limit switch, add a limit switch over to the other side of the heat strip, and providing I have power through my limit switch and power up to this point, then I can come over and I can energize this section over here for this heat strip. The only thing that's left is my line 2, my second leg of power, to complete the phasing. I'm going to come off, and I want to protect this with a limit switch, and as you can see, that limit switch has already been taken up. So I'm going to come over first into my limit switch over here, come out of my limit switch, land it on this side of the heat strips, providing there's power here because I have my fuse block is provided with power on both sides of the fuse, meaning the fuse is closed, power through my contactor, power up to this side, limit switch is closed, I have power here, then naturally I'm going to have power here. So now I have 2 contactors controlling 50% of my heat strips, and I have, for a total of 100%, I have my center limit switches protecting 50% of my strips by themselves, and then I have every other limit switch has the capability, instead of knocking off 3 strips like these 2 here do, these other limit switches can knock off 2 heat strips. So if I have 1 limit switch out, 2 contactors pulling in, then I'm going to lose, 2/3 of my capacity. I'm sorry, 1/3 of my capacity. If on 1 strip, yeah, 2/3 of my capacity. So I was right on that. 2/3 of my 50%. I'm going to go ahead and pick a different color to indicate, there we go, my other strips. So I got 1, 2, 3, and then we'll say 4, 5, and we'll say this is 6. So we'll say this this is 4, 5, and 6, and this other contactor is 1, 2, and 3. Try to make this as simple as possible for you. So yeah, one fuse goes to 1, 2, and 3. The other fuses go to 4, 5, and 6. So there's 6 fuses here. If I lose one fuse, it doesn't affect the other contactor. If I lose 2 fuses on the same leg, then it's going to affect both contactors. But very seldomly are you going to walk up on a no heat call and have these heat strips present, you know, the entire thing not working. It's going to be part of it's not working, the other part is working. And so you have to be able to know how to run your meter, test, you know, what's open, what's closed. You know, if I'm reading 208 or 230 volts, say it's 208 volts, then I'm going to read 2 volts, 0 volts or 208 volts. So if I'm ever reading 0 across the fuse, 0 volts across the fuse, then that means the fuse is closed. If I'm reading 208 volts across the fuse, then that means the fuse is open. If I'm running 208 across a limit switch, then that means my limit switch is open. So you can simply just sit there and look at all this spaghetti and go, let me just see what's open and what's closed real fast. 0, 0, 0, 0, 0, 208. Okay. Well, 1, 2, 6, 5, and 3 are all with power, or all the limit switches are closed, and 4 has a open limit switch. And it's pretty simple. Contactor's not pulling in, and I'm running 24 volts up to my limit switch. Well, I'm going to backfeed common on the other side, so I'll read 24 volts or I'll read 0 volts. So if it's 24 volts and 0 and the contactor's not pulling in, then I know I have a limit switch that's open here, and that's causing my contactor not to pull in. So it's, like I said, it's either 0 or 24 path of electricity. So common all the way back. If I had an open heating element, meaning the strips were open, then, you know, I'm going to read, if it was open on this side, then between the limit switch and between the element, I'm going to read a difference in power as well. So like I said, either 0, if it's 208, then it'll be 0 and 208. If it's 230, it'll be 0 and 230. I'm going to read 1 and 2, whether it's an open limit switch. If the contactors, for example, is open, okay, then I'm going to read across the contactor as well. In typical most cases, you know, we're simply going to go across the limit switch or across the fuse, because that's typically where our issue is going to be. Like I said in another video, if the contactor is not pulled in, you'll clearly be able to see that it's not all the way pulled in, and that's pretty simple. You know, are we getting 24 volts to begin with? Yes, we are. Okay, well, I got 2 limit switches. I can see these bouncing off of, are they open or closed? Are they open or closed? Okay, if everything's closed and my contactor's not pulling in and I'm getting 24 volts over there, it could be a bad contactor. Go to the contactor and see if I'm getting coil voltage on that contactor. If I am and the contactor won't pull in, place the contactor. So there are scenarios where, you know, the contactor can just be bad too. There's a lot to these. If you're already on 3-phase heat strips and you have a good understanding of single-phase heat strips, whether it's 5 kilowatt, 8 or 10, if you understand the safeties, then you're definitely ready to dive into 3-phase heat strips. The best way to understand 3-phase heat strips are you're only running a strip with 2 legs of power. You're not running 3 legs of power to heat strips. You're running 2 legs, L1 and L2, L2 and L3, or L1 and L3, and that's all we're doing. We have another video that we put out there for 3-phase heat strips. It's not as elaborate as this. You know, I'm not going to put another one out because all it would be is a bigger rectangle with more limit switches and more L1s, L2s, and L3s, ceramic pieces, and more bolts, and probably a 3rd contactor, and it's just more of the same stuff. All it is just another layer. And so if you're on this and you're saying, man, that is confusing, well, then you're ahead of the game. Back up, go to something that you can better understand, simply understand it. Dive into 5 kilowatt. Because if you think about it, this is the same technology as one 5 kW heater. If you look at what I've done here, here, and here, right? I've got 2 legs of power, 1 limit switch, not even a fusible link. Go to my 5 kW video, you'll clearly see just that. So all we've done is we've taken that 5 kilowatt heater and we stamped it out 6 times. That's another way of looking at it. And instead of using a fusible link to break my other leg of power, I just put a fuse block down here and put a fuse down here. There's, however you got to look at it to simplify it. Just remember, the complexity is not here. The complexity is you're not understanding something. And I'm trying to help untie that knot inside your head the best as possible. Everybody's got a different way of showing these videos. If I were to, you know, get some heat strips and simply try to go over it this way, or maybe we stick this inside of an electrical furnace and turn a fan on, and there's not a whole lot of room here for me to get a meter, and pretty much I'm going to be standing in front of it. If I'm standing off to the side, I can't really get a clear view of this myself, and it already looks confusing, you know, and you're not going to sit there and wait for me to wire up every terminal, right? So it's just, that's a very difficult way, in my opinion, to show somebody how to do this. I have this very expensive board here. This thing is close to a little over $14,000. It's an educational board to show technicians in our company, you know, step-by-step process so they can speed up their learning curve and become, you know, good quality technicians out there that we need in this industry. So hopefully this style of teaching helps you, but this is what we prefer to use as an instructional tool. Again, if this is confusing for you, don't throw the towel in. You're not ready for this much wiring on 6 sets of heat strips. This is the best way I think that we can break it down, and I hope this video does help those that are experienced enough to better understand the simplicity behind it. Thank you.